Welcome to our new video. In this video we are discussing about traveling salesperson problem using branch and bound. The traveling salesperson problem TSP involves finding the most efficient route that visits a set of cities exactly once and returns to the starting city. Branch and bound is an algorithmic technique to solve optimization problems, including TSP. It systematically explores possible solutions, pruning branches that cannot lead to an optimal solution. This method helps reduce the search space, making it more efficient for solving combinatorial optimization problems like the TSP. Let's understand that how to solve traveling salesman problem using branch and bound with the help of a state space tree. Creating a state space tree begins with node 1, allowing transitions to nodes 2, 3, 4, or 5. Node 1's cost is determined from the reduced matrix, set to 25. The initial upper bound is infinity. Moving from node 1 to 2, set first row and second column as infinity in the matrix. Since we can't go back from 2 to 1, make 2 to 1 also infinity in the matrix. Reduction occurs. Cost of reduction for node 2 is 10, 25, 0, 35. The reduced matrix has at least one 0 in each row and column. Find minimum values for each column. First column's minimum is 11, others are 0. Moving from node 1 to node 3, we update the matrix by making the first row and third column infinity. To prevent going back, we set 3 to 1 as infinity. This reduction gives a cost of 53C1, 3RR 17, 25, 11. The matrix is reduced as each row and column has at least one 0. Moving from node 1 to node 2, we update the matrix by making the first row and second column infinity. Since we can't go back, we set 2 to 1 as infinity. This reduction gives a cost of 35T1, 2RR 10, 25, 0. Next, we find minimum values in each column, 11 for the first column and 0 for the others. Adjustments were made in the matrix, and a reduction cost was determined. This procedure continued for node 3 and node 5, each time adjusting the matrix and finding minimum values. As we explored node 5 further to node 3, costs were updated and the tree was pruned. Ultimately, the optimal path identified was 14253. The entire process was aimed at minimizing costs and finding the most efficient route through the state space tree. Thank you for watching.